So in this video, we're going to take a look at some of the reactions, the nuclear reactions that happen inside of stars. And we're also going to use that as an excuse to look at so-called nuclear reaction notation, a shorthand way of showing nuclear reactions. So let's first start with D. So D is hydrogen, or otherwise known as heavy hydrogen, because it is a hydrogen atom. Normal hydrogen would have one proton in the nucleus and no neutrons, so it would have an atomic weight of 1. But if we add a neutron to hydrogen, then we can have hydrogen that is heavy, and so we still have just one proton in the nucleus, but we have an atomic weight of 2, one proton plus one neutron. We can write this as an H and use the typical symbol for hydrogen, but we also call this by another name, deuterium, or sometimes simply heavy hydrogen. So you'll see letter D oftentimes. It's not in the periodic chart, but when people write that when writing nuclear reactions, they mean this heavy form of hydrogen that has a proton of 1 and is chemically exactly like hydrogen. All right, so what happens to D? We can take deuterium and we can add a proton. How do we want to write the proton? We can write it like this, or we can write it like that. A proton is simply this fellow here. So a proton is simply a hydrogen atom. It could be written this way, but we'll write it as a proton, and that can react, that can fuse together inside of a star to give us helium-3 plus some gamma radiation. Here's another reaction. We can take lithium that forms by some other reaction. We can react it with a proton. It can give us helium-4 and another helium-4 atom. And then we could take beryllium with an atomic weight of 7, and that has 4 protons in its nucleus. That can react with a neutron. We'll write it as an N with a 0 because it has no charge. And that could give us lithium-7 with an atomic number of 3, and that can release a proton. And I just want to show how we can write these fellows in shorthand. The way we normally do this, I'm going to squeeze it above this first equation here, since we're running out of room on the right. We would have the parent, that's this guy here, so that's D21, that's the fellow that's going into the reaction. It's going to react with a proton, and then it's going to release some gamma radiation. So we'll put that after the comma. We'll close the parentheses, and then we'll put the products. The products are going to be helium with an atomic weight of 3. So that's for this equation here. We've got some room over here, so we'll write this one to the right. This is the starting material. So we have lithium 7, and we're going to have the open parentheses. It's going to react with a proton. That's a P with a plus sign, and it'll release a helium atom. It doesn't really matter which one we choose. They're both the same. And then it's going to create a helium atom. So we can write the reaction like that. Then for this guy here, we have beryllium-7, atomic number of 4. That's our input material. It's going to react with this neutron here, so that will go to the left of the comma. It's going to release a proton, so that'll go to the right of the comma, and then we can write lithium-3,7 here as the product of that reaction. So these are some various reactions that occur inside of stars. They can release a very large amount of energy, again using Einstein's famous equation of E equals mc squared. There's a little bit less mass on the right-hand side than there is on the left, and that loss of mass is equal to a gain in energy. So we could write plus E on the right-hand side of all of these. So there's a lot of energy that's released. And then when people write these reactions, sometimes we use this kind of notation here rather than writing out the full equation like this.